This is China's Greater Bay Area. It is home to 86 million people, generating an economic output approaching $2 trillion. But the region's growth is physically fractured by the Pearl River Estuary, a massive waterway that forces high-volume shipping into constant logistical congestion. 800 miles north, the Yellow River creates a similar divide, separating the urban core of Jinan from a strategic pilot zone for free trade and innovation. Surface crossings like bridges are already running at maximum capacity. To further integrate these economic zones, engineers are forced to move the traffic directly beneath the riverbeds. These geographical bottlenecks are now the primary threat to regional economic growth, pushing construction into the most hostile environments on Earth. To maintain clearance for global shipping lanes, the ShenZhong Link had to reach a depth of 113 meters below the seabed. At this depth, the project faces exactly 11 bars of hydrostatic pressure, the weight of the entire ocean pressing down on the excavation face. This pressure is the same force experienced by a deep-sea diver at 120 meters. If the tunnel's pressure seal fails for a second, millions of gallons of water and liquefied earth would instantly breach the zone, crushing the structure. Compounding the pressure is a chaotic geology of 13 separate layers, including marine sediments, shifting fine sand, and active fault zones. Conventional tunneling methods cannot survive these conditions. Overcoming this environment requires a machine designed to actively push back against the weight of the water. These crossings rely on massive tunnel boring machines, like the Shenzhong 1 and Shanhai, 5,200-ton behemoths with cutting diameters reaching 17.5 meters. This is the slurry balance shield. The machine's cutting face is isolated by a front excavation chamber filled with a dense bentonite mud. This mud is precisely calibrated to match the external pressure of the river. By keeping the chamber pressurized, the TBM creates a mechanical barrier that prevents the seabed from collapsing inward. A dual-circuit system manages the flow. One pipe delivers fresh slurry to the face, while a second pipe sucks the mixture of mud and excavated rock out to a treatment plant on the surface. During the Yellow River crossing, the machine encountered a layer of dense, sticky clay that threatened to coat the cutting tools and stop the bore. To solve this, engineers installed jaw crushers directly into the active slurry line. This allowed the machine to chew through the clay without stopping or ever releasing the critical internal pressure. These mega-machines survive by operating as sealed, pressurized ecosystems, capable of swallowing geological obstacles while protecting the workers inside. Behind pressure cutter head, a continuous assembly line installs 500 precast concrete rings to build the permanent tunnel. The operation moves at a rate of 18 meters a day, simultaneously carving the earth and paving the path behind it. But for the crews assembling these rings miles underground, the greatest threat is invisible: the risk of asphyxiation in a dead-end tube. As the tunnel grows, air friction and leakage make it impossible for oxygen to reach the face naturally. Engineers must deploy complex combined ventilation systems to force breathable air through miles of piping. These machines operate as a pressurized submarine and a mobile life support system, isolating the construction crew from the crushing weight of the deep. The final sprint under the Yellow River required boring directly beneath the primary flood defenses, where a settlement of more than 5 millimeters could have breached the embankment. Breakthrough occurred on day 110, completing a 2-mile tunnel section in a fraction of the usual construction timeline. In June 2024, the ShenZhong Link opened to traffic, marking the completion of an 8-lane highway crossing built through 6 active fault zones. The commute across the Pearl River Estuary dropped from over 2 hours to under 30 minutes. This reduction in travel time merges labor pools and industrial hubs that were previously isolated, allowing these cities to operate as a single, hyper-integrated economy. By navigating these limits of pressure and geology, these projects have converted the Pearl and Yellow Rivers from permanent barriers into traversable arteries, proving that even the most volatile estuaries can be bypassed through targeted, high-pressure engineering.